Hello again. We are now going to go over factoring quadratic trinomials, which is number 14 through 23 in your review packet. So for all of these, this is where we have to find our combinations of numbers. So for number 14, we are looking for two numbers that when you multiply, you get negative 12, and when you add, you get negative 4. So two numbers that works with is negative 6 and 2. And now you can go ahead and put them straight into the two binomials. There's no other work required. And you get x minus 6 and x plus 2. For number 15, again, you want to do the same thing. Two numbers that when you multiply, you get negative 24. And when you add, you get 10. Those two numbers are 12 and negative 2. So I can, again, go right to my parentheses and do x plus 12 and x minus 2. For number 16, you have a coefficient of x squared, which means now instead of just looking for two numbers that when you multiply you get 10, you have to do 10 times 2. So now you're looking for two numbers that when you multiply you get 20 and when you add you get 9. Those two numbers are 5 and 4. Now in this case you can't go straight into putting them into the two binomials. You have to actually do either that shorthand method of taking the two numbers and dividing them by a, or you can do the factor by grouping, either one. I'm just going to be demonstrating the shorter hand method, which is now to simplify the fractions, and the bottom number gets the variable. So 4 over 2 simplifies to 2 over 1, and that's actually a 1x. So now my two binomials are 2x plus 5 and 1x plus 2, or just x plus 2. Same thing for number 17. I have a coefficient of x squared, so therefore I'm looking for two numbers that when I multiply I get 3 times 2, which is 6, and when I add I get 5. Those two numbers are 3 and 2. So I'm going to now take that 3 and 2 and put them both over the a value and simplify. 3 over 3 simplifies to 1 over 1. 2/3 stays 2/3, and the bottom number gets the x. And now I'm going to write my two binomials, which is x plus 1 and 3x plus 2. For number 18, you want to do the same thing. Two numbers that when I multiply I get negative 90 and when I add I get 13. These might take you a little bit longer to do because there are a lot of multiples of negative 90. It's kind of a larger number. But there are two numbers, 8 and negative 5, that work for this. Or 18, I'm sorry, excuse me, and negative 5. So I'm going to take that negative 18 over 15, or sorry, positive 18, excuse me, and negative 5 over 15, and now simplify them to 6 over 5. The bottom number gets the variable, and negative 1 over 3, and again the bottom number gets the variable, and put them into your parentheses, which is 5x plus 6 and 3x minus 1. And number 19 is a little bit unique because if you notice there is a GCF of all of these, so it's probably better to take out the GCF. Now you could do this problem with doing 12 times negative 9, that adds up to negative 3, but you're going to be working with a lot bigger numbers. So I'm actually going to take out the GCF first, which is 3, and I'm left with 4x squared minus x minus 3. Now I'm looking for two numbers that when I multiply, I get 4 times negative 3, which is negative 12, and when I add, I get negative 1. Those two numbers are negative 4 and 3. So now I'm going to take those two numbers and write my two fractions, negative 4 over 4 and 3 over 4. Simplify them. I'm going to be left with negative 1 over 1, and still keeping that 3 over 4, but the bottom number gets the variable. So now I have that 3 times x minus 1 times 4x plus 3. So again, that one's a little bit more complicated. You could have gotten the same result, except for it would not be factored completely. You would still have one of these binomials that had a GCF. For number 20, you should recognize the pattern in number 20, that the first term is a perfect square and the second term is a perfect square, and I have a minus symbol. That means that this is a difference of squares, and that's x minus 7 and x plus 7. For 21, you have the same thing. I'm sorry, you don't have the same thing. In number 22, you have the same thing, but we'll get there in just a second. For number 21, this one does not have coefficients of x squared. Therefore, all you need to do is to find two numbers that when you multiply you get 48, and when you add you get negative 26. Those two numbers are negative 2 and negative 24. So therefore I can go straight to my two binomials, so I have x minus 2 and x minus 24. Again, like I was saying earlier, number 22 is a difference of squares. 16x squared is a perfect square, and 1 is a perfect square with a minus sign. So therefore, you know that the square root of 16x is 4x. The square root of 1 is 1, plus and minus. And for the last one, again, you're looking for two numbers. There's no coefficient of x squared. So you're just looking for two numbers that when you multiply, you get negative 36, and when you add, you get 9. Those two numbers are 12 and negative 3. So therefore, I'm going to put them right into my parentheses x plus 12 and x minus 3. This concludes the review of factoring.